Hey, we're on to concept 2 here. More about right triangles. This time we're going to talk about the two different kinds of special right triangles. The first type of special right triangle is a triangle that is actually an isosceles right triangle. It has two congruent angles, 45-degree angles, and of course one 90-degree angle. So we call this a 45, 45, 90 right triangle. And we're going to have a relationship here between the legs of these triangles. And that is that the two sides across from the 45-degree angles, you should probably know this already since we talked about isosceles triangles, those sides are both going to be equal. And we like to call them S. And over here you can see that S I'm using is the length of the leg here. So if both of these sides across from the 45-degree angles is S, then in this special triangle, the hypotenuse is S times the square root of 2. So this helps us if we know we have a 45, 45, 90, and we know just one of these sides, we can find all of the sides. So let's try that. Here I have a 45, 45, 90 right triangle. And I'm given that the hypotenuse is labeled H, and this leg is labeled 9. So I want to find the missing side. In this case, the missing side is the hypotenuse, it's H. So what I recommend doing is going around and using the relationship from the previous page and labeling the triangle. So we'll label the two sides across from the 45-degree angles S. And since this is 9, I'm just going to write 9 equals S. They represent the same thing. My hypotenuse was S radical 2, or S root 2. So H equals S root 2. And you can see I kind of formed here now two equations. If we had this third side labeled, we'd get a third equation. But we know that this side S should be equal to 9. So I'm just going to organize that here. S equals 9. I also have that H is equal to S root 2. We know that S is 9, so we can plug that in here for S. We get that H is 9 root 2. So we found the missing side length even though we only knew one side. So let's try that again here. Got another 45, 45, 90. Again, I'm missing the hypotenuse. This time we call it X. And I'm given that one leg is 2 root 2. So we'll go label them using our relationship. The two sides across from the 45-degree angles are S. And the hypotenuse is S root 2. And again, I put equal signs in here for the ones where I have labels, and I have created now two equations. So I'll organize that again. S is equal to 2 root 2. X equals S root 2. So we're going to take that 2 root 2 and plug it in for S. You should always plug in using parentheses. So I get 2 root 2 times root 2. Now if this is something that's uncomfortable for you, I do have a quick review video posted, and you should go check that out. And it's a little quick reminder of how to multiply square roots and also how to rationalize denominators, which you'll have to do. So I can multiply root 2 times root 2, and that gives me 2 times root 4. We know that the square root of 4 is 2, and we can multiply one last time and get that X is 4. So again, if this was a little confusing to you, this multiplication of the radicals, go ahead and check out that review video. The other type of special right triangle is a 30, 60, 90 right triangle. This relationship is a bit more complicated. This time S is the length of the short leg of the triangle. And the short leg is always across from the 30-degree angle. It's not always on the bottom. It's always across from the 30-degree angle. That's a common mistake. So you need to check to make sure which side's across from the 30-degree angle. This longer leg across from 60 is S times the square root of 3. and then the hypotenuse is 2 times s. So let's use that. Here I have a 30, 60, 90. I have that x is across from my 30-degree angle, so this is my shortest leg. So x is equal to s. 60 is across from this guy, which is not labeled, so we'll just say s root 3. And then 40 is my hypotenuse, that is equal to 2 times s. So again, we can write these equations. I'll start with 40 equals 2 times s. Here I have to solve for the value of s, which I think should be pretty easy. All we need to do is divide by 2, and we get that s is 20. So up here I've already written x is equal to s, so it's pretty easy. We plug in 20 for s and get that x is 20. Just as a quick note, even though I didn't ask you to do this, if I took s and I plugged it in and I wanted to find the longer leg, I would just plug in 20 here, and that would give me 20 root 3. So I could actually find the other missing side. So let's try one more. Again, I need to make sure I label this correctly. This one's a little more tricky than the 45, 45, 90. The side across from 30 is s. The side across from 60 is s root 3. So here I have x is equal to s root 3. And my hypotenuse is 2s. So it looks like I have another equation right here, 2s equals 10, that will help me find the value of s. And just as kind of a reminder, just a little bit of a heads up, s is just, it's just another variable that we're using to help us solve these types of problems. So we can solve that quickly, just divide by 2 on both sides and get s equals 5. So we can see kind of quickly the side that we're not even looking for, but I'll do it anyways. This short side is 5. And we see that x is equal to s root 3, so all we need to do is plug in 5 for s, and we see that x is 5 root 3. So go ahead and try these two problems, one for each special right triangle. And again, if you struggled a little bit with radicals, or if you know you need a little refresher, there's a quick review video. You can check that out, and hopefully it will help you.